Understanding how to read a vulnerability report is a foundational skill for anyone entering the field of cybersecurity or DevSecOps. Whether you are reviewing a report produced by a penetration tester, an automated scanning tool, or a security team, you need to be able to extract the right information quickly and accurately. This course walks you through the anatomy of a vulnerability report using a fictional but realistic example, explaining each section, the terminology used, and why each element matters in a professional context. You have already explored the Open Web Application Security Project Top 10, mapped security checks onto a delivery pipeline, and practiced placing security tests into existing workflows. Now it is time to understand what the output of those tests actually looks like in written form. The Vulnerability Report. What is a vulnerability report? A vulnerability report is a formal document that communicates the findings of a security assessment to its intended audience. That audience may include developers, system administrators, project managers, or executives, each with different levels of technical knowledge. A well-written report must therefore be both technically precise and readable by non-specialists at the summary level. Vulnerability reports can be produced manually by a human tester following a penetration test, or automatically by tools such as static analysis scanners, dynamic analysis scanners, or software composition analysis tools. In professional practice, the two approaches are often combined. Automated tools detect a broad range of potential issues, and a human analyst validates, contextualizes, and completes the findings. The overall structure of a vulnerability report. A standard vulnerability report is divided into several distinct parts. Each part serves a specific purpose. Here is a walkthrough of those parts using a fictional report on a web application called ShopEasy, a fictional e-commerce platform. 1. Cover page and metadata. The first page of a vulnerability report identifies the document itself. It typically includes the name of the assessed application or system, in our example, ShopEasy v2.3, the name of the organization that requested the assessment, the name of the tester or testing team, the date of the assessment and the date the report was issued, the classification level of the document, for example, confidential, internal use only, a version number of the report, for example, version 1.0, initial draft. This metadata ensures traceability. If a vulnerability is later disputed or re-evaluated, the document version and date allow everyone to refer to the exact state of the system at the time of the test. 2. Executive Summary. The executive summary is written for non-technical readers such as managers or executives. It provides a high-level overview of the assessment without going into technical detail. In our fictional ShopEasy report, the executive summary might read: a security assessment of the ShopEasy e-commerce platform was conducted between April 10 and April 14, 2024. A total of 12 vulnerabilities were identified, 2 critical, 4 high, 4 medium, and 2 low. The most severe findings relate to broken access control and a SQL injection vulnerability in the product search feature. Immediate remediation is recommended for the critical and high findings before the next production deployment. The executive summary sets the tone, gives a sense of the overall risk level, and provides a clear call to action. It must never assume deep technical knowledge from the reader. 3. Scope and methodology. This section explains what was tested and how. It defines the boundaries of the assessment, called the scope, and describes the techniques and tools used. In the ShopEasy fictional report, the scope would specify the uniform resource locator, web address, of the application tested, https://staging.shopeasy.example.com. The parts of the application included in the test, for example, authentication module, product catalog, checkout flow, user account management. Any parts explicitly excluded from the test, for example, the third-party payment gateway, was out of scope. The type of assessment: black box, no prior knowledge of the system; gray box, partial knowledge; or white box, full knowledge including source code access. The tools used, for example, Burp Suite for web traffic interception, Nmap for network scanning, and manual testing for logic flaws. Defining the scope clearly protects both the tester and the client. A tester cannot be held responsible for vulnerabilities in systems they were not authorized to assess. This is why the scope section often references a signed authorization document. 4. Finding Summary Table. Before diving into individual vulnerability details, most professional reports include a summary table that lists all findings at a glance. This table typically contains a unique identifier for each finding, for example, Vuln 001, Vuln 002, the title of the vulnerability, the severity level, the affected component or endpoint, the remediation status, open, in progress, resolved, This table allows a team to prioritize remediation work quickly without reading every finding in detail. 5. Detailed findings. This is the core of the report. Each vulnerability is documented individually and in depth. Let us look at how a single finding from the fictional ShopEasy report would be structured. Finding title: SQL injection in product search unique identifier, vulno 01 severity, critical affected component, /search endpoint, parameter query, discovery date, April 11, 2024. Description: the product search functionality fails to sanitize user input before including it in database queries. An attacker can manipulate the query parameter to inject arbitrary database commands, potentially exposing all data stored in the database, including user credentials and payment history. Proof of concept. The following input was submitted in the search field: OR1 = 1. This caused the application to return all products in the database rather than filtering by any search term, confirming that the query is executed without input validation. Impact. An attacker could extract the full database contents, modify or delete data, or use the database server as a pivot point for further attacks. This vulnerability directly threatens the confidentiality, integrity, and availability of user data, the 3 pillars of information security you have previously studied. Recommendation: use parameterized queries or prepared statements in all database interactions. Never concatenate user input directly into a database query string. Implement server-side input validation as an additional layer of defense. References. This vulnerability corresponds to Open Web Application Security Project Category A03-2021, Injection. Risk rating rationale. The severity is rated critical because the vulnerability is remotely exploitable without authentication, requires no special privileges, and can lead to full database compromise. Key terminology explained. Severity and risk ratings are among the most important elements to understand when reading a report. Here are the most commonly used terms. Critical: a vulnerability that can be exploited remotely, without authentication, and that leads to full system compromise or major data breach, requires immediate action. High: a vulnerability that is easily exploitable and leads to significant data loss or unauthorized access, should be remediated as a priority, typically before the next release. Medium: a vulnerability that requires some conditions to be exploited, for example, the attacker must already be authenticated, or that has a limited impact, should be remediated within a defined time frame. Low: a vulnerability with minimal impact or that requires very specific and unlikely conditions to be exploited, should be tracked and addressed in due course. Informational: a finding that does not represent an immediate risk but reflects a configuration or behavior worth noting. For example, a web server returning its version number in HTTP headers is informational. It does not directly cause harm, but it gives useful information to an attacker. CVSS, Common Vulnerability Scoring System, a standardized scoring framework used to assess the severity of vulnerabilities on a scale from 0 to 10. A score of 9.0 to 10.0 is critical, 7.0 to 8.9 is high, 4.0 to 6.9 is medium, and 0.1 to 3.9 is low. You will frequently see this score referenced in professional reports. CVE, Common Vulnerabilities and Exposures, a public catalog of known vulnerabilities, each assigned a unique identifier such as CVE 2023-12345. When a report references a known vulnerability, it often includes its CVE identifier so that teams can look up additional details and patches. Proof of concept, a minimal demonstration that a vulnerability actually exists and can be exploited. In a professional context, this is evidence that the finding is real and not a false positive. It may take the form of a screenshot, a crafted request, or a short script. False positive, a reported vulnerability that turns out not to be a real security issue upon further investigation. Automated tools are prone to false positives. Human review is essential to filter them out. Remediation, the action taken to fix a vulnerability. This could be a code change, a configuration update, a patch, or an architectural redesign. Attack vector, the path or method an attacker uses to reach and exploit a vulnerability. Common attack vectors include the network, remotely over the internet, adjacent network, requires local network access, and local, requires physical or local access to the system. Authentication bypass, a type of vulnerability that allows an attacker to access protected resources or functions without providing valid credentials. Access control flaw, a vulnerability where users can access resources or perform actions beyond what their role or permissions should allow. This maps directly to the Open Web Application Security Project category Broken Access Control. 6. remediation plan and prioritization. A good vulnerability report does not just list problems, it helps the team understand what to fix first. The remediation plan section organizes findings by priority, suggests a timeline, and sometimes maps findings to specific teams or developers responsible for the fix. In the Shop Easy fictional report, the remediation plan might look like this: immediate, within 48 hours, Vuln 001, SQL injection, critical Vuln 003, authentication bypass, critical, short-term, within 2 weeks, Vuln 002, insecure direct object reference, high Vuln 004, cross-site scripting in comment field, high, medium-term, within 1 month, Vuln 005 through Vuln 008, medium findings, long-term or backlog, Vuln 009 through Vuln 012, low and informational findings. This prioritization directly supports what you have already learned about shift left and feedback loops. The goal is to catch and fix vulnerabilities as early as possible in the delivery process, and the report gives the team the data they need to do exactly that. 7. Conclusion and sign-off. The final section of the report summarizes the overall security posture of the assessed system, acknowledges the limitations of the assessment, and may include a statement of retesting conditions. For example, it is recommended that a retest be conducted after critical and high findings have been remediated to verify that fixes are effective and no new vulnerabilities have been introduced. The report is often signed by the lead tester and acknowledged by the client's security point of contact, ensuring formal accountability on both sides. Why this matters in your career path. As a DevSecOps specialist or cybersecurity professional, you will encounter vulnerability reports constantly. You may be the person writing them after a penetration test, reviewing them as a developer expected to fix the findings, or integrating their output into your continuous delivery pipeline as part of automated security gates. Understanding the structure and terminology of a vulnerability report allows you to quickly identify what is urgent and what can wait. Communicate findings accurately to both technical and non-technical stakeholders. Integrate security results into your pipeline decision-making. For example, blocking a deployment if a critical finding is detected. Avoid acting on false positives and waste of remediation effort. Produce your own reports that meet professional standards. The fictional Shop Easy report used throughout this course is a model you can reference whenever you need to recall how a real report is organized. Each section has a purpose, each piece of terminology carries meaning, and each finding follows a consistent format that makes the document actionable rather than merely informational.